One thing I noticed with several people that came in asking questions is make sure you're using correct format. So you're showing a proof, you really need to write down the problem on these, not just one side of it. So you're writing the problem, that way you can box in one side and I know which side you're working with. Otherwise, sometimes it's a little hard for me to follow your work. Our strategy yesterday was to box in the easier side and try to work for it. Sometimes there's not necessarily one side that's easier than the other. You know, if I'm looking at this, does one side seem easier? Not really. So I'm just going to pick one and box it in. Okay. So look at what I have. We always look for any obvious identities, but the Pythagorean identities require our functions to be squared, and none of these are squared, so we can't use those. Then we go to sines and cosines, but we already have sines and cosines. We could try to separate this fraction, but if you look at our goal, we want one big fraction at the end. So really even pulling this fraction apart doesn't seem all that beneficial. One strategy that we have not talked about yet is you can multiply top and bottom by the same thing. Now we did that getting a common denominator, but here I'm going to multiply by looking at this one. We want a cosine and we want a 1 minus sign, right? I have 1 plus sign. I have the conjugate. So sometimes multiplying top and bottom by the same thing is helpful, especially if it's a conjugate. So I'm going to multiply by 1 minus sin x on top and bottom. On the top, if I do that, I get 1 minus sin x and plus sin x cancel. Minus sin squared x. On the bottom, I could distribute, but I'm not going to, because look at my goal. I want a 1 minus sin x. I'm hoping this cosine will disappear. So I am not going to multiply it through the 1 minus sin x. I'm hoping I can just get it to go away. Any ideas from here?
The Pythagorean have to be squared. Okay.
So 1 minus sin squared x is? And now what can happen? And left with cosine x over 1 minus sin x. And that's what we wanted. Any questions on that? Any thoughts? Which side do you want to box in? It's not really right or wrong. So if you don't know, pick one. Which one do you want me to try? Okay. And we know worst case scenario, if we get stuck, we can come back and try to work that side and get them to the same point. Okay, so looking at what I have, I do have a cotangent square cotangent squared would be equal to? Okay, that Pythagorean identity. Okay. What do you want to do now? We could. I wish that was for pass. We could try factoring. We could try changing things to sines and cosines and simplify. Cosecant squared minus 1. That's a difference of squares, isn't it? It would be cosecant x plus 1, cosecant x minus 1. Okay, keep our goal in mind. We may be taking a slightly odd path to get there, but I think we can still get there from this point. We want that cosecant x minus 1 on the bottom, so that's good. I don't want the cosecant x plus 1, and I don't want the 1 plus sine x on top. I just want a plain sine x. So we have some different options. What I think might be helpful here, what if we do what we did on the last one, where we multiply something on top and bottom? We are trying to get a sine x on top, just a plain sine x. What would happen if I multiplied sine x on top and bottom? So on the top, I don't really want to distribute it because I'm hoping this 1 plus sine x will cancel out. On the bottom, the cosecant x minus 1 is good. That's what I want. You can multiply any two things. So if I multiply these two, what happens if you take sine times cosecant? If you don't see that, take a second. Cosecant is 1 over sine. So now if I distribute it through that parenthesis, sine x times 1 over sine x is 1. 1 times sine x is plus sine x. And I still have my cosecant x minus 1. But that's actually really good for us. Because now what will happen? Now we have sine x over cosecant x minus 1. That was kind of a weird one. Maybe it was the path we took. Sometimes you might take a longer path than other times. It's okay. You just work through it. You can still get there. If you need something in your fraction that you don't have, you can introduce it in as long as you multiply on both top and bottom by that thing. Right. Let's try this one. All right. Not real nice. What do you think? Which side do you want to try to work with? Or which side do you want to try boxing in? Don't really know? Okay. This one looks like it might be challenging. Let's box in the right. At least it has sines and cosines. Maybe that's easier. The left, we don't have any Pythagorean identities because they're not squared. So we could try just changing sines and cosines. We want sines and cosines in the final answer. Cotangent is cosecant is from here, you notice all four of these have a denominator of some. I told you it's legal to multiply top and bottom by the same thing. So what if we multiply top and bottom of this fraction by sine theta? When you do that, cosine over sine times sine would just give us a cosine. Minus sine times 1 over sine is 1. On the bottom, cosine over sine times sine is cosine. Minus sine times 1 over sine is 1. Oops, that's supposed to be a plus on the bottom. Okay. Any thoughts on how to get from there to where I'm going? No? So what can we do if we get stuck? Okay. Don't just get mad and erase all your work. We're going to go work the other side and see if we can get it to be the same. Notice how everything I have that I'm looking for is cosines. So let's change the bottom. Sine squared is 1 minus cosine squared, right? So a negative sine squared. So that's the opposite of 1 minus cosine squared. On the top, we did an example yesterday with factor. Cosine squared, cosine and a constant. We can factor that. What multiplies to 1 and adds to negative 2? On the bottom, if you distribute your negative, you get a positive cosine squared minus 1, which is a difference of squares. So the bottom would factor into cosine theta plus 1, cosine theta minus 1. And then, since we have the same thing on top and bottom, those cancel. And we work it to the same point. Alright, any questions on that one? Let's try more.
So hopefully.
You saw my email. Okay for you.
What should I box in? Yeah. This side doesn't have fractions, so let's box that in. And we know if we get stuck, we'll just come back and work it as well. So if we look at where we're going, our goal that we just boxed in is things being multiplied. That means we need to add these fractions together. If you are going to add fractions, what do you have to have? Common denominator. So I have to take this one times 1 plus cosine x on top and bottom. And this one times 1 minus cosine x. So if I distribute, I get sine x plus sine x cosine x. On the bottom, if you FOIL, you get 1 minus cosine x and plus cosine x cancel. Minus cosine squared x. Minus, and this one, sine x cosine x times 1. Sine x cosine x. Times negative cosine x would be negative sine x cosine squared x. And then FOIL on the bottom. Since the denominators are the same, we can put them together. We have to distribute the negative. So my denominator stays. So on top we have a sine x plus sine x cosine x and minus sine x cosine x cancel. Sine x cosine squared x. Look at our goal. I really don't think we're too far off. What do you notice about both terms on top? They both have what in them? A sine x. Let's factor that out. That would leave us with a 1 plus cosine squared x, which looks familiar. I want a 1 plus cosine squared in my answer. On the denominator, what is 1 minus cosine squared x? Then what happens? Sine cancels. We're left with a sine on the bottom, and sine on the bottom is the same thing as you need to think of it like this. We have a 1 over sine times the 1 plus cosine squared. So that is our cosecant x some harder ones today. Maybe didn't take the most direct path on all of them, but it's okay because we found out we can get there anyway, and if we get stuck, we go work the other side. Do you guys want more examples, or do you want to try them on your own now? Try on your own and let me know. So you should have your problems from yesterday, and if you are stuck on any of those, now is the time to get help. And then we are going to add 8 more.